Physics Part 169. The amplitude of the wave motion is defined as the maximum displacement of a particle in the wave. Also, it can be seen that the wave repeats itself. This is, the wave can be constructed by repeating a section of the wave. The length of the smallest repetition unit is called wavelength. One wavelength is the distance between two neighboring peaks or two neighboring troughs or two neighboring points which are vibrating together in exactly the same way in a phase. It is the distance moved by the wave during one oscillation of the source of the waves. The usual symbol for wavelength is A, the Greek letter lambda. The usual symbol for the wavelength is lambda, the Greek letter lambda. Another way to represent both waves is to plot a graph of displacement v against time or time t. This is shown in the figure again. Again, the wave repeats itself after a certain interval of time. The time for one complete vibration is called period of the wave t. The period of the wave is the time for a particle in the wave to complete the vibration or one cycle. Displacement of time graph for a wave. The number of complete vibrations cycles per unit time is called frequency f of the wave. For waves on ropes and springs, the displacement and amplitudes are measured in mm, m, or other units of length. Period is measured in seconds. Frequency has the unit per second, or hertz, a term used to describe the relative positions of the crest or troughs of the two waves. The same frequency is called phase. When the crests and the troughs of the two waves are aligned, the waves are said to be in a phase. When crest is aligned with the trough, the waves are out of phase. When used as a quantitative measure, the phase has the unit of angle radians and degrees or degrees. Radians or degrees. Thus, when waves are out of the phase, one wave is half a cycle behind the other. Since one cycle is equivalent to 2 pi radius or 360 degrees, the phase difference between waves that are exactly out of phase is pi radians or 180 degrees. We can consider the figure in which there are two waves of the same frequency but with a phase difference between them. The period t corresponds to a phase angle of 2 pi rad or 360 degree. The two waves are out of step by a time t. Thus phase difference is equal to 2 pi t over t rad. 360 into t over t degree. A similar argument may be used for waves of wavelength lambda, which are out of step by a distance x. In this case, the phase difference is 2 pi into x over a, x over lambda, which is equal to 360 into x over lambda. These are phase differences. One of the characteristics of a progressive wave is that it carries energy. The amount of energy passing through unit area per unit time is called intensity. Intensity of the wave. The intensity of the proportional The intensity is proportional to the square of the amplitude of a wave.